This is all now posted on Google Classroom, all the solutions written out with some hopefully helpful notes and all of my tiny unit circles. We're going to look at 14, 15, 16, 32, and 44 in just a minute, so you can go back and look at all these online. Okay, so looking at 14. 14 has 3 different trig functions, and they're not all in sine and cosine, and none of them are cosine squared or sine squared. So what we need to do is what we did in 7.1. First, we need to change tangent into sine and cosine. So we can try to manipulate this into a place where we only have one trig function somehow. So tangent, which one is that? Is that cosine over sine or sine over cosine? So we've got sine over cosine, which means we really have sine squared x on the top. Everybody see that? That's good. You could probably, no, that's still going to leave 1 over cosine, so that doesn't help many. Because I was going to try to replace that with something and see if that canceled, but I still have a 1, so that doesn't help me. So what I need to do is make this into the same denominator. Right now it's over 1. And that means I'm going to multiply it by cosine over cosine. So then the next step, I can sort of put it all together. Is everybody on the same page there? Okay, so now I've got this one over cosine, this one over cosine. I'm going to write it as cosine squared x plus sine squared x all over cosine of x. How about cosine squared plus sine squared? How much is that? That's 1. So 1 over cosine of x equals 2 over 1. Now what? You can multiply both sides by cosine of x. You can cross multiply. You can actually take the ratio and just flip it over, which is what happens if you were to cross multiply. Let me just show you that that's legal. Because now when you divide by 2, you get cosine of x equals 1/2, which is the same as if I had taken this, flip this over to get cosine, and flip this over to get 1/2. Yeah? So that's pretty cool. Does cosine of x equal 1/2 anywhere helpful? Because now we have a place we can look at the unit circle. Cosine is positive here, and nope, here, cosine. So if cosine is 1/2, that means it's going to be the over 3's, pi over 3, and 5 pi over 3. These are not a pizza slicer across from each other, so I need to put them both with 2k pi. Pi over 3 plus 2k pi. 5 pi over 3 plus 2k pi. Correct. Because the distance here is big. This looks like a Pac-Man now. And this part is big and this part is little. They're not the same. I can't go from one to the other and back with the same distance. So I have to consider each point separately. And to get all the iterations of pi over 3, we add 2k pi. To get all the iterations of this, we have to add the whole circle. Waka, 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 waka. Okay, 15. Okay, 15. It's not all in sine and cosine, but do we have anything handy that we could replace? So this whole, okay, 1 plus 2. Yeah, so with this is going to be 1. Every time you see sine squared and cosine squared and an addition sign, no matter what the order, this is 1. So now I have 1 plus tangent squared x. So tangent squared x equals -1. Does that mean something we can solve? Yeah, so it's imaginary. So what happens is this is 1 plus something equals 0. That would mean that this has to be negative. So in this step, you might have noticed that any squared thing is positive. So I can't add this and get 0. And then you get here and you type this, try to take the square root, and you can't. So you stop. And then you think, I wonder if this is really right. So you pull your calculator out, because this is homework, and you investigate further and find out that they don't cross. If you put this in as y1 and set it equal to 0, it must be all the way above or all the way below. Probably all the way above because it's positive, right? That would make sense. It never crosses the x-axis. So we could graph that and see. Anybody want to graph it and see? Okay. So we were just going to take a look at this. Remember, when you make cosine squared, you can't put the 2 here. So you have to put these parentheses around the whole guy and put squared. Otherwise, it would just square the x, not the cosine function. So when we graph it, it is above the x-axis. Neat. So no solution. I mean, with homework, you should investigate other ways. I think having a visual is just like confirmation. No solution is cool. I'm good. 16. Cosine squared of x equals 3 cosine squared of x. We have cosine squared and sine squared. What do we want to do?
I just made one of them.
You pick one. So pick one. Who asked for 16? Which one do you want to change?
I just did the cosine one because there was like less to multiply. So it's just 1 minus sine squared.
All right, so cosine squared equals 1 minus sine squared of x. Hopefully this is becoming something that you could write on the side, but you kind of already see it happening. So now we have it all in sine squared. So all we do is we add another one over here. So plus sine squared x. We have 1 equals 3. Oops, I can't add. Oh, my eraser's gross. 4 sine squared x divided by 4. 1/4 equals sine squared x. So how do we get sine all by itself? We don't want sine squared, we just want sine. Square root. Square root, square root, plus or minus. No. All puppies should be healthy after this process. So we've got plus or minus. We now have sine of x. We can take the square root of 1/4 because square root of 1 is 1. Square root of 4 is 2. We have plus or minus 1/2. So we have all of the signs being a half. So we have all 4 quadrants. So sine is a half here, right? Square root of 3/2, a half. And here, and here, and here. Ooh, we have the guy from Star Wars, right? Kinda. No, it's like the thing that flies. No, this is the Death Star. Like the little things. Okay, forget it.
Oh, I know what you're talking about. It's like a spider ship.
Okay, so spider ship.
It's like a spider.
Yeah, I don't know what it's called. I'm sure they have a
Do you
name.
watch Star Wars, or like are you just like?
We have a Star Wars Christmas tree.
Yes, but have you seen Star Wars?
No, but we have the spider ship ornament.
Okay, so these two guys are a pizza pie slicer away from each other. So all I have to do is list is one of them, pi over 6 plus k pi. That takes care of this one. And this one, here we have 5 pi over 6 plus k pi, and that's all 4 of them infinitely around and around the circle. Yay.
Yay.
And if we had done the other one, we would have had, I guess we would have had square root of 3/2 somehow, because we would have multiplied it out and had to factor it if we did it in terms of cosine. So we would have looked at other values. So that was 16. Do this in prior classes, verify their solutions, pi over 6. So we're going to find secant of pi over 6. Well, if you don't like secant, what can you do instead? So 3, 1 over cosine squared of pi over 6
Or you can use that shared diagonal.
minus 4. You could.
That's what I just said. Tangent squared x.
Yeah, but this is, you're still stuck with tangent.
Yeah, and then I just used tangent.
If we go this route, what's pi over 6 in cosine? We were just at cosine. We were just at pi over 6. What is it? Okay, so we've got 3 times 1 over the square root of 3 over 2 squared minus 4, which is kind of gross in itself, but not that bad. What's the square root of 3 squared? So 3 over 4, flip it over. So we have 3 times 4 over 3 minus 4 equals 0. Yes. So if you weren't sure what to do, it's a matter of either replacing it with something else where you could bring it to the top so it doesn't confuse you if you didn't like secant, or turning it into cosine, because this isn't that bad. It means evaluate cosine at this value and then square it. It seems to be in the wrong order with the 2 here, but that's what we're doing. So we find pi over 6, we find the cosine value, we square it. We use fraction math, which is also hard for some people. But it turns out that we get a true statement, therefore it is a solution. Same words we've been using forever. And then for B, it says 5 pi over 6. So 5 pi over 6 is also, nope, it's negative. But then you square it, it's still going to be positive, right? So do I really have to do that one? It would look like this. And then you square it, and it would be positive. And it would still work. So the squared saved the day. I had less writing to do because I'm out of paper anyway. So that was 32. And then we're going to try to graph 44. So let's pull that up. We're putting number 44 in the calculator. It's a reciprocal function, so secant squared. So we're testing out the idea that squared on the outside works. It won't square this. Now, in handwriting, I'm not going to know what you mean. I really need for you to put it here or use parentheses, because y'all really might mean x squared, and I don't trust you yet. So what am I doing? I'm doing the reciprocal. 1 divided by, so fractions easier. Secant goes with cosine of x, parentheses. We're trying out this squared on the outside. Squared. Oops, that's not it. Go back. Hello, thank you. Delete, delete, delete. 44 squared. Okay. 44. Any more to that problem? No. Equals 0. Okay, and then I was just going to compare it, because that's fun, to parentheses, fraction, 1 divided by, I think this is what Madeline was saying, tangent of x, parentheses, squared.
That's why I think that's why I thought it.
Well, that should be the same.
I think I put like a bunch of extra parentheses and I got.
Oh, well, no, that happens too. And then subtract, parentheses, fraction.
Because I just graphed it the way we did at top and it works. So.
Okay. Secant is cosine. I know this is super obnoxious to watch in a video. It's probably just as obnoxious live. Anyway, so pretty. Ooh, they're the same. Okay, we're going to find one that doesn't work, so we'll know what to do and not to do. They asked us just from 0 to 2 pi. This graph is overwhelming. So instead of looking at it, I just want to look at the window that includes just the 0 to 2 pi. So I'm going to type in 0 and then 6.28 because I'm lazy to find the pi button and graph that. And now I only have 4 zeros. I can find this one and this one and this one and this one. Do y'all need me to find the zeros, or are you good there? So one of them would be secant, calculate 0, because it says equals 0, so that's what I'm finding is zeros. So I want to get on this line, so I'm going to say, like, maybe I'll just move my arrow. Where am I?
I don't think you hit the 0.
I didn't? Well, let's try that again then. Secant, calculate 2.
Oh, yeah, you did
Okay,
that.
better. Okay, so what can I say? I'll say 0.1, and I'm somewhere on this line, and then now I'm below it. You have to be above and below so that it can find it in the middle, and then guess it's going to find that one. So if they said 4 decimal places, that's good. I'm glad we could write all 4 so we don't have to leave it at 3. And then you would find the next one by having to move over to the other line. So you'd have to find 0 again and then move over here. So if I said 2, 2, it's already on that line. We found out yesterday that if we weren't on the line, it couldn't find it. It couldn't cross the asymptote. It's not that smart. So then you would move above it so that it has a below and above, and there it is. Okay, so you would find all 4. It's nice, right, to move it to the window so you only see those 4. Then you don't have to guess where 6 is, and you know it won't take you an entire day. There's just these 4 places. So get comfortable changing your window because it's so easy, and it's so easy to zoom back to standard with just zoom 6. Okay, so how are we doing? Better?
Yeah.
All right, let's look at what we're working on for tonight. We're still in the same section. We're still solving equations. Let me see what kind of problems we have and if we need more info. So we're going to do one example for the homework tonight. Most of the other ones are familiar to you. You're going to use a trig identity to switch stuff out if you aren't sure how to solve it. You do have to factor some. There are some that they ask you to graph, and that's good because they've mixed up some for us in these problems that we have for tonight. There's like a logarithm equals a sine equation. What does that mean? It means you just put in y1 equals the logarithm equation they give you, and y2 equals the other side of the equation, and find out where they intersect. So not any more difficult, but would be difficult to solve because they have different inverse functions, right? So you don't want to be mixing logarithms and trig. There aren't identities that help with that. So algebraically, not in our level. I don't know. It would be a high level class, yeah. But with a calculator, we can solve it easily. So that's nice that we understand that you can look at a picture and solve the same thing. Okay, so here we are. Our example for today, because we've got a kind of one that has a different kind of answer, is 6 sine of x minus 2 equals sine of x. And we're just asked to do it in one revolution around the unit circle. So we just have to find this one answer. So what we want to do is solve for it and find out what to do if we get it. So this is still 7.4. This is a new sort of example. I mean, it's the same, but it has a different sort of answer. So let's look at it together so that y'all don't panic if you see it. This question is all in sine, so that's good. We don't need to change out anything. It's set up like an algebra problem. So I need to get all the sine on one side and all the numbers on the other side so we can try to solve for it. So what do I need to do first? Subtract sine of x. Get the signs on the same side. That would be good. Sine of x. So now we have 6 minus 1 is 5 sine of x. Can I go ahead and throw the 2 on the other side? Is everybody comfortable with that? Okay, so now we have 5 sine of x equals 2/5 because I've divided by 5. So sine of x equals 2/5. Well, yeah, roadblock. We don't have this on the unit circle, but could sine of x equal 2/5?
Yeah.
Because it's less than 1. So sure it does. I don't know where it is though. So how do I write this mathematically? We did some stuff like this when we were doing logarithms and exponentials. We just left it in a form where we said x equals something that would need to go in a calculator. So we need inverse. So we need to just rearrange this so we could say x equals. So we would take sine inverse of both sides. And I never, ever leave enough room. Even though I know I'm going to do that. X equals sine inverse of 2/5. And then you're done. Like this is it. I don't know what it is. I would need a calculator. They didn't say use a calculator. And so they've got decimal answers. This is for 21 through 23. Well, it's really 21 through 30. You might have some answers that would require a calculator. You can just stop here. So, but I wanted you to be familiar with that. And this is a fine answer. It's something that represents the answer, but is not a decimal. So the calculator could find it. The rest of them are just a continuation, more practice so that you are doing a little bit and we get to go over it so that hopefully you're not overwhelmed. Do you feel like you have some mastery of what we're doing? Okay, it's getting better with the 2k pi and stuff. I think many of the ones you have tonight are just in the 0 to 2 pi. But feeling comfortable with this is fantastic because this is actually called the transcendental functions. It's not just algebra. So it's good to feel like you have a grip on what it is that we're doing. So practices for tonight, there are solutions already posted, and I think there's actually a video of solutions already posted. So if you have questions, you can answer them tonight, and what doesn't work for you, we can talk about tomorrow before your quiz. Okay? Okay.